This and the following videos of this module are dedicated to explaining and detailing the relational model. In this video, we will briefly talk about the history of the relational model and reason about its popularity. We will relate the relational model very briefly with the SQL language, which will concern us in the rest of the course. And finally, we will introduce the basic concepts of the model. The relational model, as we have mentioned in previous lessons, is a data model used during the logical design phase in order to specify in detail the system as a whole. That is, what are the entities or relations, what are their constraints, etc. Now, the relational model is a very simple model. However, it has a very strong mathematical foundation, which makes it a strong and viable choice for database design. The relational model was introduced in the early 70s by Ted Codd of IBM Research. As it is a very simple model and it has strong mathematical foundation, it instantly attracted attention. The model uses mathematical relations that are the table, simply put, of values, and it has its basis on set theory and first-order predicate logic. These topics are quite advanced and therefore we won't address them in this course, but it suffices to know that the model has a very strong mathematical foundation. The first commercial implementations came out in the early 80s. One of them was the SQLDS system by IBM. Another was Oracle's DBMS. The wide and long-lasting popularity of the model stems from its simplicity and its strong theoretical basis. Even nowadays, with so many other alternatives available, the relational model remains very popular and used extensively in commercial DBMSs. No matter which model is used in the DBMS you will be working on in the future, if that is what you end up doing, knowledge of the relational model is required at all costs, because that guarantees good database design and development, but also good software engineering. Now, you might have heard about the SQL language or structured query language. This is the standard programming language for storing and processing data in commercial relational DBMSs, and we will dedicate some weeks to learn how to use it. But here I just would like to mention that the SQL language is based on the relational model and was invented also almost as early as the model itself in the 70s. The relational model has three basic concepts: the relations, the tuples, and the attributes. A relation can be thought of as a table. In the relational model, a database is represented as a collection of tables or collection of relations. Each relation would typically correspond or model an entity type of the real world. Then a tuple or a row, as the name suggests, is a row of that table or relation, and it represents a real world entity or relationship. And then the attributes or columns correspond to the columns of those tables and specify how to interpret the data in that column. Now, since each column or attribute corresponds to a characteristic, let's say, of the entity type modeled in the relation, all the values in one particular column have to be of the same type. For example, if the attribute is age, then all the values in that particular column, which correspond to the ages of the entities stored in each row in the table, need to be either all of them integers or all of them floats or all of them strings. That's a choice, but it has to be the same. The header of the column gives a description of the attribute. It's the attribute's name, simply put. So here you see an example of a schema in a diagrammatic representation. So in this example, we consider a database that keeps and processes information about everything that's happening at an institute, let's say OPIT. It keeps information about its students, its professors, the courses, the grades that the students have at each course, etc. Now here we just show 5 of the relations, 5 of the tables that they are perhaps part of that database. Each table has some columns or attributes. Each column represents a feature, some information about the entity type described in that table. For example, in the student relation, we have as attributes name, student ID, program, and supervisor. This is merely a schema. All it tells us is what information is to be contained in each table. Later on, we will see that we can add information on the schemas about the dependencies across features and across relations and the constraints that we impose. So this is not the database itself. This is just a representation of it. And at this point, we just define the schema. There are no entries in it. There's no records, no information about any student or any professor, etc. So when we start adding information, that will appear as rows in these tables with specific information. But again, that would be the representation, not how the data is actually stored in the physical medium. But this is how we organize it and view it to make our lives easier, let's say, for maintaining and use of the data in the database. And here is an example of some of the tables, the relations that we saw earlier, populated now with some data. So now let's revisit the concepts of the relational model on this particular example. So now we have the names of the relations. These appear on the top of each table typically. They correspond to the names of the entity type that is modeled by each relation. And then we have the actual relations, the actual tables, which contain the data of the entities. On the top of each row of each relation, we have the headers of the attributes or the headers of the columns. They give us a short description of the data found in its column. They are the names of the attributes. So here, the first column in the student relation is the attribute name. And what we need to store here for each record, for each row, is the name of every student modeled in this database. Each column is an attribute with a header, the description of the attribute, the name of the attribute, and then the values of that attribute for each record in the database. Lastly, we have the rows, or typically called tuples. These are the records for each of the particular entities in the database. So here, for example, in the case of the relation student, this tuple contains all the data, that is, the values of each of the attributes specified that correspond to this person here, this student, this entity of the student entity type. So to sum up, the relational model, which was introduced in the early 70s, has become a standard in database design due to its simplicity and its strong theoretical foundation. In this model, a database is represented as a collection of relations or tables. Each relation contains attributes which correspond to the columns and tuples which correspond to the rows of the table. All the values of an attribute are of the same type, and each row contains values for the attributes for a particular entity.